All right, in the second video, we're going to be talking again about building SQL expressions, and again, we're by no means going into all of the components of SQL. We're really going to deal with them as they relate to queries. You can certainly look at the PDF document included in the class for week 3 to get into more detail. But for today, let's really think about what we're going to be doing with these in terms of examining our data. So let's begin with the idea of comparison operators. Comparison operators are what you would think of from your basic math class as equal to, less than, greater than, less than or equal to, greater than or equal to. When we use comparison operators in a query or in a selection, essentially what we want to do is say a field, some comparison, an operation if you will, and then a condition. Now these can be numeric. In other words, for example, we have a field that is population in 1990, and we want any of those polygons where the value is greater than, in this case, 17,735. But we could also compare two fields. Population in 1990 is less than the population in 2000. Or we can use comparison operators in a sense to alphabetize, to select a subgroup of a text field based on the order. So if you imagine the names of counties and we say we want the names of counties that begin with J or later in the alphabet. So again, J through Z would be greater than or equal to J. If we wanted J through A, in other words, or A through J, then we would say less than or equal to J. We could also use somewhat more complex comparison operators where we calculate a group of fields or a field plus a value and compare it to another field. So we'll see this one when we get into ARC. We have our HUC 12 areas and their land use in acres has been calculated. So for example, the acres of row crops for a HUC 12 plus the acres of hay pasture, and if we add those two together, we could kind of conceive of that as agricultural land. We want to know those HUC 12s where the agricultural land, those two fields, is less than the total forested cover. And so again, we can use some combinations of fields and mathematical operators to combine them, to divide them, etc. And so we're going to use these examples when we look at basic comparison operators. Okay, so let's begin with that first idea of a quantity. And so we're going to look at our counties here, and we're going to say we are interested in a very basic form of query that says population 1990 is less than, and we'll get our unique values. We can look at that, and we're going to say, well, we want to get those that are less than 20,000. We'll put that in, okay, and apply. And you'll notice that these are the counties that have that criteria. So again, if we look at them, we'll, not surprisingly, we'll see that in this case, our 1990 population, okay, here it is, and it's less than the number we threw out there. All right, so let's go back and let's look at our query. And in this case, again, less than 20,000, and so that's what we results. So in other words, an absolute value and a field that's numeric. Now let's change that. We're going to clear that out. And again, what I'm interested then, for example, is counties that had growth. That would suggest that our population in 2000 is in fact greater than our population in 1990. So population 2000 is greater than population in 1990. I'm going to apply that. And now we see these are the counties that have that characteristic. These are growth counties. Again, if we look at our query, we've said population in 2000 is greater than population in 1990. So we can compare two fields in this case. As I noted earlier, we can also, though, do a sort in a sense. We can select those that meet a certain order, if you will. So in this case, again, I'm going to clear this out, and we're going to say name, and in this case, we want it to be, we're going to go from J down, so we're going to say less than or equal to. And in this case, we can do it a couple different ways. We could grab one of these. But again, important idea, because we have a single or an apostrophe, that means that this field is text. And so what I'm going to do here is I'm going to put in the apostrophe, the J, and another apostrophe. And so what this will say is it's going to return all of those counties whose name starts with A and goes all the way to starting with J. I'm going to hit OK and apply. And there are A through J counties. Those are the basics of kind of the simple operations. Now I'm going to change our data frame here. And what I want to do is somewhat more complicated analysis that I suggested in the slide. So let's take a look at our attribute fields here before we get into the query. If we look at our fields here, what you'll notice is down towards the bottom, we have calculated areas. Okay, that's the calculated acres here. And then within that, though, you'll notice that we have things, for example, like open water, bare ground, quarries and mines, deciduous forest right here, evergreen forest, mixed forest, and then again we have hay, pasture, and row crops, and other grasses. Now what I'm going to do is we're going to ask the question where agricultural land and forest differ. So I'm interested in those those Huck 12s where there's more agricultural land. I'm going to start with that one than there is any kind of forest. In other words, all of the forest combined. So let's take a look at how we would do that query. Well, what we know is we have to take and we have to add first on one side. Again, we're interested in agricultural land greater than forested land. So here we go. We're going to start with our agricultural land, and we know that there are two that fit into that. So in this case, we're going to use hay pasture plus, in this case, row crops. And I'm going to say that I don't necessarily know, but I believe that the grasses are what we would call standard pasture. So we're going to use that one as well. And so we're going to say these three we want to be greater than the combination of, we're going to use mixed forest plus evergreen forest plus deciduous forest. Okay, now, so what we've done is we're asking the question here, where are the Huck 12s where essentially agriculture area exceeds forested area? And again, that's a rather complex comparison. And we're going to apply that. And there we go. In Pennsylvania, those are the Huck 12s where that is in fact the case. Now we could then actually calculate that as a ratio, but now we have in a sense the geography of that. So again, in this case, what we've done is some basic comparisons, field to field, field to absolute value, or complex of fields to complex of fields. Those are your basic types of comparison queries. Let's go back now and look at some other options though. We have comparison operators, and we also have the ideas of likes and not likes. When we want to look especially at text fields, oftentimes we have a couple of reasons to do things that simplify or generalize our queries. For example, we might have a group of tree data, and we actually want to pull out all of the tree data for any kind of maple. In other words, there's several different species of maples, and they're listed in the familiar table. In other words, that's the field familiar. And they might have sugar maple and silver maple and red maple and tiger maple. But we really want any of the maples. And we're going to learn to use something called a wildcard. You'll notice here the wildcard is the percent sign. The percent sign allows us to say any characters, in this case, prior to the word maple. Now we could also say we want everything that's not maple. And in this case, we're going to use the not in front of the field, and then like, and then our wildcard. Okay, so again, remember, the percent sign is a wildcard of unlimited spaces. Wherever it goes, there can be an unlimited number of characters there. There is a single space wildcard, and I want you to think about this. Imagine that, and remember that when we do these types of queries, they are case sensitive. Imagine that some of the people entering data entered small case M for maple, and others entered large case. Well, we want just maples, but we need to make sure that that first letter can be treated as either a capital or a lowercase. Or imagine something like you have the term Catherine, a name. We don't know whether people spelled it with a K or people spelled it with a C. By using a single space wildcard at the location of the C or K, we'll get back both options. So let's take a look at how this runs. All right, we are back in our ARC map, and what I'm going to do here is we have campus trees in Slippery Rock. And what I want to do is, again, look at these by species, and we want to begin to pull out certain kinds. So we go in here, and I'm going to open up, again, my definition query. And you'll notice that we have familiar, and I'm going to say like. Familiar is like. I want to get all the unique values. And you'll notice, for example, that we have black ash, we have sycamore, but in this case I'm really interested, and you'll notice here's a very important idea. Here's black ash and B space LACK space ash. Well, that's somebody that did, in a sense, an error in data entry, and I would need to capture both of those. And so in this case, what I could do is simply say like, and now I'm going to say open, and I'm going to use my wildcard, and I'm going to type ASH, and I'm going to close it. Now what that's going to do in this case, OK, and apply. Now let's take a look at my attribute table. And what you're going to notice in our familiar here is I get red ash, white ash, black ash, and this strange little one here that has a space in it. And I can look in that and I can either do a correction of that, but I've got all of the ashes here. Now I can invert this argument. I'm going to go back into here, and I'm going to go back to my query builder, and I'm going to clear it. And this time I'm going to say not familiar like. And again, in this case, I know that I have those ashes in there, and I'm not interested in them anymore. So I'm going to put in there not like ash. And now you'll notice, by the way, I'm going to leave these over here. You'll see these three. And I'm going to hit OK and apply. And now what I have, if we look for our attribute fields, what we don't have, and we're going to sort these so that we can see this, you'll notice that my black ash, which should be right in here, is not present. So we've set everything except that. Okay, everything except that. Now, this can be used rather in some really complex ways, but some really useful ways. You'll notice here that we have North Hall. Southwest of North Hall, we might have next to the pond, next to East Lake parking lot. We can use likes to begin to look for things in complex text strings. So you'll notice in this case, I'm interested in North Hall. Okay, North Hall is a fairly large building, and lots of trees exist on different coordinates from it. So I'm going to do a somewhat more complicated query, and I'm going to say, I'm going to open up my definition query, and I'm going to say, rather than this, I'm going to my query builder, and I'm going to say, I'm going to clear this off, and in location, I'm going to say like, and then again, I'm going to put in my open quotation mark, or my open apostrophe rather, my wildcard, and then North Hall. Okay, and apply. And what you'll notice here is that, in fact, I was able to query a, if you will, a description, and I get everything that says west, side of, front of, all of these things have North Hall in some way in the location description. And I'm able to pull that out using that like. And again, I could also say not like North Hall. Either way would allow me to deal with that idea of the likes. It is also important to understand that these types of similar, or if you will, generalizing queries can be used to deal with ideas of absent data. Okay, and I want you to think about what that means. There are really three types of absent data. When we talk about absent data or empty attributes, we really can conceive of three of these. There is a scenario where a text field, or in fact a number field, doesn't have anything in it. In other words, it's simply an empty cell. There are also situations, though, where that cell is populated with what we call a null field. And when we get into raster data, you're going to see that null fields sometimes are produced by that or by forms of calculation. Then the third option is that in some cases we will populate an area that doesn't have a value. We don't want it to treat it as null, so oftentimes we'll put a negative value, and oftentimes that's a negative 999 or a negative 9998. What we're going to use is the field name is null, or the not field name is null. If you're looking for those that are not null, you're going to put the not at the front. If you're looking for those that are null, you're going to just simply put is null. Now remember, that is has to be in front of the null. Okay, so let's take a look at that. On here is I've actually calculated, just to give you an idea of how this works, I've actually done a calculation field. And as a result of my calculations, some of the fields, again, this is a numeric field. In this case, it's a double precision field. And when the calculation was performed, some of the fields were not calculated, or some of the cells rather were not calculated, and so they have the null value. Now that is different. This null is very different than having a text field that does not have a population in it. That's a very, very different idea. You'll also notice over here in the level field that the levels, we have levels 1 through 7 here, but in some cases levels were not calculated, and so rather than putting a null value in it, a negative 9998 was entered. So these are different ways of seeing the non. So what we're going to do here is we're going to examine how to deal with, of course, these null values. So let's look at the query builder. And remember, the first one I want to deal with is the null field. So we are interested in those that are not null. So we start with the not. And we're going to say not, the length kilometer, and remember is null. Okay, so again, not, then the field is null. Hit OK and apply. And you'll notice that now what I have are all of those that we have a length calculated for. It's important to say, okay, that deals with a null field. And I'm going to change this again. I'm going to clear that out. And what I want to show you, it's a very important idea, is that remember that we had other fields that had zeros in them. For example, we had some of the IDs had no values, but they weren't zero, they weren't null fields. So let's take a look at again what our attribute table looks like, and let's deal with how we're going to solve some problems here. So you'll notice here, level has these negative values. Our name doesn't have anything in it, but it's not null. And then our length, if we sorted that, you'll notice would also have some null values in it. And so we have to deal with all of these possibilities. Okay, so let's close that. And we're going to look at this. And we're now going to say within this, so these are all the non-nulls, and so I'm going to clear that out and apply that. So now I've got everything back. And in this case, I want to now deal with our name. And in the case of the name, I want all of those, I only want the named streams. So in this case, though, I can't use a null because it's not a null field. It's a field that doesn't have any text. So I'm going to say name is, in a sense, what we want to say is we don't want it to be equal to something. So again, we're going to say not. We can use nots. Not name. And in this case, we're going to say is equal to, oops. And we're going to get our unique values. And here we're going to say we want it to not be name is equal to that empty. You notice this is two of the apostrophes with nothing in the space. When I do that and apply it, what I get are only, in this case, and we're going to open up our attribute table, only those where there is in fact a name. I'm also going to do that with the fields that have those negative values in it, because I want to deal with that again. It's a slightly different issue. So again, we're going to go back in, open up our attribute table, and we're going to clear that. And we're going to hit apply. So we got everything back. And in this case, we're going to go in and we're going to say, you'll notice that we had this field here that is its ID. And what I want to do is first I want to make sure that we have, this is the one with those negative values, or I'm sorry, this is the one again with a empty field, text field. And so we would say again, in this case, we want to identify all those that are blank. Hit that and apply. And now we're going to see that. And you'll notice these also, in this case, have the names. Now, level is the field. You'll notice here, level is a numeric field. And so rather than having nulls, or rather than having empties, it has a negative value. So now we have to deal with those as well. That's another option. So again, here, we're going to clear this off. Clear a query builder. And OK. And apply. And now let's go in and build a new one. We're going to say in this case, our level is equal to, and let's get our unique values here, and we want to not have these. So if that were the case, what I would do is enter that in, and if I look at that, I say, well, okay, wait a minute, I want anything that's 1 or above. So this is a relatively easy one to deal with, and I'm simply going to say I want anything that is level greater than 0. And we're going to apply that. And again, that deals with all of those that have that odd negative value associated with it. So those are different ways of dealing with our null fields, our empty fields in text cases, and then a negative value or nonsensical value in our numeric fields. Okay, that's the end of our definition queries and our SQL introduction. Again, we'll be returning to SQL as the semester progresses.